Thanks, Rick. Hello, everyone, and thank you for attending today's webinar, What Every EH&S Manager Needs to Know About Fire Code Compliance, which is sponsored by ChemSW. Founded 2 decades ago, ChemSW is the leading provider of chemical inventory management systems, safety inspection solutions, and other laboratory software and services. ChemSW systems enable organizations to streamline laboratory processes, address regulatory requirements, and reduce chemical costs. ChemSW supports over 15,000 customers in more than 40 countries worldwide. I'm pleased to introduce today's presenters. Jeff Tarter of Integrated Engineering Services has a BS in Chemical Engineering and is a certified hazardous materials manager with extensive experience in regulatory and environmental issues. He is an expert on international building, fire and mechanical codes, and NFPA requirements relating to the storage, handling, and use of hazardous materials, as well as air quality and wastewater pretreatment standards and emergency response requirements. As a former regulatory agent, Jeff has developed numerous regulatory guidelines, served on several hazardous materials subcommittees, and actively participated on various code rewrite committees. Our second presenter, Brian Billings, is an inventory management consultant with ChemSW. Brian has IT expertise in a variety of technical languages, platforms, and concepts. He provides top-level support to ChemSW's enterprise-class customers, including on-site training and implementation services, as well as data migration and initial inventory project management. Brian has helped many organizations address a wide range of regulatory requirements, from ensuring fire code compliance of hazardous materials to accurate Tier 2 reporting to utilizing a GMP-enabled CISPRO global system. Now I'd like to turn it back over to our presenters.
All right, I guess this is Jeff Tarter with IES. To start the presentation, I guess the first slide is really, what we're here to talk about is, fire code compliance. We're looking at issues revolving around hazardous materials inventory and the building codes and fire codes that regulate them from a kind of a different perspective than a lot of EH&S managers are used to seeing. The requirements vary from typical OSHA requirements in that the codes are rigidly initiated around the building construction issues, but also from a fire code perspective, the emergency response requirements taken into consideration, safety issues for emergency responders. So part of that is there hazardous materials, compliance information, and then we're going to go into some of the challenges you have in maintaining and starting up the systems for the inventory tracking, which is the primary component of this program. And then we're going to go into some time for questions and answers after that. So the typical inventory reporting requirements that EH&S managers, always have to deal with are, usually the federal standards. I'm not sure the breakout as far as the jurisdictions where all of the attendees are from, but they're all subject here in the U.S. to the federal reporting requirements under SARA. And the problem with these reporting requirements is that it's fairly broad in that the reporting thresholds are fairly high. And so a lot of people we encounter are wondering why at the fire code or building code, the local level, the requirements are, much more stringent as far as what quantities of materials need to be reported. And part of the issue on the reporting requirements is really because the fire code and building code look at materials, not individual materials per se, but the classifications and the hazard classes for the materials. So from their perspective, they're not looking at, isopropyl alcohol, ethanol, and methanol as different entities, but all as Class 1 flammable B liquids. And the building code has specific construction requirements that if you exceed certain quantities, it elicits, a lot of actual architectural and engineering controls on those systems, as does the fire code. The fire code includes numerous requirements for labeling, containment, ventilation as well, and then the mechanical code. People sometimes ask me which is the more stringent code, and ironically, you kind of find out that the mechanical code, which everyone forgets about and everyone seemingly never looks at, is probably the most restrictive. And why I say that is because the mechanical code has no threshold limits as far as when you have certain requirements. It simply says if you have a flammable liquid, you will pipe it this way. If you need ventilation, it will be done this way. And so it doesn't really have a threshold quantity, whereas the Fire and Building Code does have some allowances based on a reportable quantity and what they call also a maximum allowable quantity per control area. Building code, if you look at where this is, the International Building Code and International Fire, International Mechanical Code for that matter, is basically a United States document. It was merged from several other organizations back in 2000, being you'll sometimes hear the Uniform Building Code. Well, that used to be published by an organization here in the West, called ICBO, and there was also building code standards, SBC and BOCA, that were used in the East and South as well. Well, in 2000, the three primary model code agencies merged into the International Building Code. So you can see in the kind of in the map, it's adopted throughout the U.S. And the difference is that some of the states you'll see are shaded. In those areas, the shading just reflects that it's not a state-mandated code, model code throughout the state. Here in California, it is a model code and it's applied throughout the state. But you look at Texas, and individual jurisdictions are able to adopt the code based on their own needs. So you look at Austin. The Austin Building Code is a little different than the Dallas Building Code. Okay? So the building code and the issues that we're dealing with primarily from a building perspective have to do with the use and occupancy of the building. They're not concerned about personnel protection. They're not concerned about anything other than the building itself and the employees that work there. So you get some requirements that are all based on the occupancy. And the occupancy can vary. Usually you'll see for typical business is Group B, a type of occupancy. Educational, Group E, you don't see too many of those in our types of industrial applications, but you do see a Group F. So the primary ones are the Bs and the Fs that we deal with. And in those occupancies, you can have a certain amount of hazardous materials, but if you exceed this maximum allowable quantity, it goes into this Group H, or high hazard occupancy. And as I mentioned previously, there's certain requirements, and we'll touch on that in a minute as far as what those requirements are. One of the things you should be aware of, especially those that live in California, here in California we adopted what we call a Group L occupancy. This is for laboratories. This was originally developed as a Group H, what we called then an H8 subdivision for use. Basically, UC Berkeley. It was intended for high-rise types of laboratory R&D facilities. There's a problem with calling it an H8, though, and so we felt that in this last code cycle, or actually a couple ago, that we broke it out and gave it its own occupancy called the Group L. The hazmat occupancies that we talked about, the BF and S, S is for storage warehousing facilities, is a control area concept where you can have it kind of compartmentalizes the amount of chemicals that you can have in a facility. You can have, say on the first floor, you can have 4 control areas, each up to the maximum allowable quantity, because those control areas are separated by fire-rated partitions, in effect compartmentalizing the storage. Once you get into an H8 category, there's some sub-classifications. The H1 has to deal with explosive types of materials. These are explosive magazines and things like that that we don't normally have to deal with regularly. The H2 we do, those are deflagration hazards. This is usually compressed flammable gases or flammable liquids that are used in open systems, whereas you may have vapors that collect in a space that could deflagrate. The H3 is for physical hazards. These are for flammable liquids that are in storage where you don't really have flammable vapors that are present. It includes oxidizers and things like that that create an increased likelihood or accelerated burning. The H4 classification, what used to be formerly an H7 in previous code editions, is for strictly health hazard materials. These are the corrosives, toxics, and highly toxics. Under the old H7, there used to be classifications or restrictions for other health hazard materials, sensitizers, and irritants. And while the fire code still regulates or has some specific requirements for those lesser hazardous materials, the quantities will not affect the occupancy. And therefore, like in a Group B occupancy, you can have unlimited quantities of irritants as long as you provide the appropriate controls. The other group for the H is the H5 semiconductor fabrication facilities. This used to be called the H6. The classification for these are requirements based specifically on the inherent risks associated with semiconductor manufacturing. This is pretty much due to the nature of the clean rooms. Either they go with a bay and chase or even sometimes a ballroom type of fabrication facility, and there's specific requirements for how much hazardous materials that you can have at each workstation, limitations on egress distances, and things like that. The semiconductor group also encompasses or is kind of taken in by the local jurisdictions to think about PV solar manufacturers, LED manufacturing. So those types of facilities or manufacturing type of processes also sometimes get grouped into this H5 category. As I mentioned previously, there's also the Group L, which is for the laboratory suites as it's applicable to California. Now, although it's applicable just to California, there are some requirements. It can be used in other jurisdictions as an approved alternate. We've done some projects back on the East Coast as well as in the Northwest and Texas as well, where this was used as kind of a nationally recognized standard to allow us to have some of these higher rise, mid-rise types of laboratory facilities. So I mentioned there's a concept in the B, F, and S type of occupancies for control area. Okay, so this is the maximum allowable quantities that are per control area. Used to be called the exempt amount, so you hear that term thrown around a lot as well. And the quantities that are allowed in a non-hazardous occupancy are broken out based on the physical or health hazards. And the code includes a couple tables that we're going to go over. The tables in the IBC are in Chapter 307. In the IFC, there's also 2703. Those are compound, the same tables though. They're just included for reference in each document. So the control area concept, if you look at this pre-2006, actually back to 2000, you had this exempt amount, and you can have 4 control areas per building. The 4 control areas could be broken out no matter how you wanted to, through basements, through multiple stories. As long as this fire-rated enclosure around the control area was contiguous, you could divide it up however you see fit. It allowed vertical, horizontal separations, and it was only a 1-hour separation. 1 hour basically is a typical 5/8-inch sheetrock type of stud construction, so it's not too difficult to achieve. The problem with the 1-hour construction is usually penetrations and things like that for ducts, and other openings and doors. Now, after this concept of control areas, when the international code kind of merged with all the 3 previous model agencies, you come up with a control area concept that's broken out by floor. So on the face of it, it seems like you could have more control areas and therefore you could have more chemicals. But in reality, once you get above the 3rd floor, it starts being very restrictive as far as the quantities of hazardous materials you can have. The amounts are prorated by floor. So this kind of breaks out the concept and thinks, okay, well, whereas the old previous concept had a review that was basically could have any type of separation and multiple floors that span in the control area, this takes into consideration on the current codes that most of the floor-to-ceiling assemblies are also fire-rated. And so you have this breakout. But it does require that the horizontal separation between floors be 2-hour fire-rated, not just 1 hour. So this prevents, or creates rather, some type of problems from an architectural design standpoint, especially in existing facilities. So you have to first make sure that you have that fire-rated separation. And another thing, it doesn't permit control areas to span floors. This became a real issue in like biotechnology type of manufacturing processes where you have a vertical integration of the manufacturing and you have tanks that penetrate through floors. You have processes that go, start on the 3rd floor and wind up on the 1st floor. And so that was one of the concerns in how you deal with that from a code perspective. And so California, they looked at it and said, okay, well, let's look at H occupancies and merge it with kind of the B area, control area concepts of limiting materials, and we'll construct it a little bit differently, kind of merge the two ideas. And so they came up with this laboratory suite concept, similar, analogous to the control areas, but it elicits a lot more construction requirements. For instance, it requires an upgraded fire sprinkler system, not just in the laboratories, but for the entire building. So you have to kind of plan this in advance from an architectural standpoint, and whether or not you can build the controls into the building at the start. So one of the advantages of it, its prorating is not as restrictive by floor. The number of suites aren't as restrictive. So it becomes much more advantageous, especially in the higher stories. 3, 4 stories is really kind of the cutoff. When this L occupancy becomes advantageous. So you can kind of see just a little graph here. It says we took an example of the Class 1 flammable liquids that are capable of being in use. And if you go with the current controlled area concept, which is the red, the quantities of chemicals, flammable liquids that you can have in use on the 4th floor is 7.5 gallons. How many of your users in a laboratory setting can limit to 7.5 gallons cumulative? It's just not practical to have that limitation put on the science. I mean, you have an HPLC, for instance, it's usually got a couple gallons on the supply side and a 5-gallon canister to collect the waste, and there you are. One piece of equipment can throw you over your limit. So the L occupancy was instituted to try and allow these larger, higher rise types of facilities. Outside of that, once you get into these H occupancy requirements, the H occupancy that the building code is looking at is eliciting specific construction requirements. It requires, for instance, the fire-rated occupancy separations that I mentioned. It requires emergency power. For typical laboratories, there's not a building code requirement to have an emergency generator for your fume hoods or the ventilation system that supports them. Only if it's an H occupancy does the building and fire code require that emergency power. Also requires increased fire protection, more restrictive egress provisions, i.e. you have to have 2 exits from specific areas. The distance to the actual exit outside the building is more restrictive. And then employs some control requirements for secondary containment and also structural improvements to the facility. Mechanical code, the exhaust systems, also has specific requirements. If you're conveying, flammable vapors or fumes in the exhaust ducts, it has specific requirements that your duct can't traverse other areas. They got to go directly to the exterior of the building. You can't manifold them. So it has real practical or applicable constraints on how your mechanical engineers design that system. And they need to be aware of the hazardous materials that the facilities are using in order to determine how to design their systems. And it's not just the flammable liquids that are a problem. Under the international code, there's a requirement that if it's a hazard ranking 4 material, and that being a NFPA hazard ranking 4, you cannot commingle the exhaust systems from multiple rooms, multiple laboratories. All right? So the fire code then also ties into this, and they're meant as companion documents. We rarely see a facility that has or a jurisdiction that employs the International Building Code that doesn't also adopt the International Fire Code. And similarly, you have a similar makeup throughout the U.S. as to whether or not it's a model code for the entire state, or if it's adopted locally on a jurisdiction by jurisdiction basis, as evidenced by the shaded areas. So you see what are these maximum allowable quantities. This is actually an old table, but it gets the same idea through, is that the maximum allowable quantities depends on user-defined information as to the condition of the materials. So if we're used to reporting requirements based on a maximum quantity under like SARA or some other toxic reporting requirement, it only usually cares about what the aggregate total quantity of materials is. The Building Fire Code, though, actually looks at the condition. The condition being that if it's in storage, closed containers, you don't open it, the quantities that you can have are much greater. They're much greater than if you have them used in a closed system, because obviously the risk associated with use of the materials and the transfer of the materials is taken into consideration here. And likewise, if you go in an open system where vapors are being emitted, the restriction for the maximum allowable quantity is much less, right? Because the hazard now associated with that use has increased. You're introducing flammable, toxic vapors into that building or into that area where your personnel are located. So then it also defines the hazardous materials classifications. And this is kind of a difficult situation to do. It's very laborious to go through if you've got 2,000 chemicals to try and define the hazard as in accordance with the fire and building code. As I said, they're based on the physical and health hazards, but the definitions are buried in kind of the beginning of the code, and there's no real authoritative database that has all of the classifications. When you look at MSDSs, they may include an HMIS or NFPA type of hazard classification. They may identify the DOT classification, but they're not going to identify the fire code classification. So the database I know that ChemSW has, they've got about 7,000 individual CAS numbers for the chemicals where that's already been defined. It's been defined based on a lot of information that is available in the MSDSs, as well as some very kind of generic guidance. And it takes some specific personnel with some chemical experience and firefighting experience to really identify some of these classifications, because it's fairly subjective. For example, the oxidizer classification. The difference between a class 3 oxidizer, which can readily ignite combustible materials, and a class 1 oxidizer, which really doesn't have that much of an impact. The difference is in how it's defined, is one having a severe increase in the building rate or burning rate versus a class 1, which has a slight increase in the burning rate. So it does become somewhat subjective at some point. Other criteria, though, are not as subjective. There's some specific requirements, and you'll see how the fire code defines toxic materials different than other codes, and you've got to be aware of what those distances are. When we talk about a fire code toxic material. It's very specific. That is based on the LD50 or LC50, and it has specific threshold limits. It also provides guidance as to what do you do with like toxic or highly toxic gas mixtures, right? If you have a 5% arsine in gas and hydrogen, is it toxic or highly toxic? So they provide some guidance as to defining it based on a summation of the partial LC50s for those gases and the individual components in that mixture. Okay. So the health hazards, when you get into it, also create a problem that really require the industrial hygienist attention to look at. The toxic classification in particular and how it's defined, because it is ever-changing. The code in the fire code is much more reactive, much more up-to-date than, say, that OSHA standards, which are sometimes lagging. And Cal OSHA also provides some requirements that are more restrictive. So it does require the industrial hygienist to look at it. And it also creates some problems from a code perspective in that even if the code doesn't change, how you treat the material does. For instance, arsine. The arsine OSHA PEL dropped down to 0.05 ppm. This created a problem for instance, like semiconductor facilities when it said I had to detect and provide continuous monitoring. And again, this isn't necessarily for personnel protection, but like an OSHA would, but it says from a fire code perspective, I've got to monitor these highly toxic gases at the PEL. Well, you cannot get a continuous field system capable of monitoring the 0.05 parts per million. There's too many interferences, and you get a lot of false positives. So the fire code in this case actually changed and said, okay, since most of these gases are used in exhausted enclosures or closed systems, they actually changed the code to say you only have to monitor in those exhaust enclosures that have the ideal age, and that you don't have to monitor them all the way down to the PEL. Similarly, you've got issues like hydrogen fluoride. Hydrogen fluoride, when you get down into the PEL of 3.0, it's not too much of a problem to monitor at that point, but to get any lower, you really have an issue. Like if you want to monitor at the TWA or TLV, you know, at 0.5, 0.4 ppm, that's a real problem for the field continuous monitoring systems that are available. And also the monitoring systems that are out there, there's actually a restriction on the technology that's out there. So you're going to pay dearly for it, and there's a lot of other regulatory requirements actually just to employ those types of monitoring systems. Some other changes that I want to touch on just from the code perspective, and like I said, it is ever changing. In the 2009 International Code, you had additional classifications that were input. The corrosives, toxics, and highly toxics, which basically used to just have a maximum allowable quantity based on gas at standard temperature pressure. It was modified in 2009 to include a different threshold for liquefied compressed gases. It was recognized that there was, it was difficult from a regulatory perspective to look at gas at standard temperature and pressure. And so they looked at using liquefied compressed gases that are portable quantities under like DOT, which were in pounds. So they actually added classifications or separate classifications for the liquefied compressed gases. The liquefied compressed gases, for instance, went from 810 cubic feet at standard temperature pressure to 150 pound in the cylinder. In the corrosives and toxic classification, you may ask, you know, how they got the 150 pound limit. Unlike normal when a lot of code is kind of just pulled out of thin air or agreed upon in committee, there was an actual basis for this, and they agreed upon the quantity limits based on chlorine in this case. They looked at 810 cubic feet of chlorine is 150 pounds in the cylinder. Similarly, for highly toxics, they instituted a 4-pound limit for the liquefied compressed gases, and the 4 to 20 was based on actually arsine. So that's where that data, came from. Also, you should be aware of in the appendices now in the fire code, which does recognize the appendices are not officially part of the code unless the local jurisdiction or authority having jurisdiction adopts the appendices. It's similar to standards, nationally recognized standards. They're not really part of the code unless they are specifically adopted, but they're still a good reference. And one of the appendices that you need to be aware of is the Appendix H, which is based on the NFPA 704 hazard ranking system. These are the diamond placards that the NFPA initially came up with, and they also threw in a numbering system to address special hazards. The numbering system being from 0, having no hazard, to 4, being having an acute or immediate hazard. So you used to just see things like oxidizers. Well, an oxidizer is a class 1. Previously, didn't make a difference whether it was a 1 or even a class 4. You would still include oxidizer in part of the special hazard sections of the NFPA placard, the white section at the bottom. And similarly for like water reactives and things like that. So the hazard material requirements based on the fire code break them into hazard classes. Mentioned previously, they're not looking specifically at individual materials. They're looking at classes for materials. Okay, so you got to be aware of that. The class requirements based on class, they can affect this, as well as the FPA hazard ranking system can affect how the code regulates these materials. It defines when you are required to provide exhausted enclosures. If you're using, like class 3 or 4 hazard ranking materials in an open system where fumes are generated, you've got to capture and exhaust those fumes at the point of generation. It doesn't provide any type of guidance as to what is an adequate ventilation system, though. So that's where the industrial hygienists really have to take an important role in also helping the mechanical engineer design those systems to make sure you have adequate capture velocities, make sure you have adequate dilution and overall CFM ventilation rates. The fire code hazard classes can also define or affect what the container types are. For instance, flammable liquids. You can't have, we're running this issue on several instances right now where you're dealing with totes, intermediate bulk containers. They sell them, they ship them all the time in plastic containers, polyethylene totes. The fire code does not allow flammable liquid storage in those totes, though. So ironically, although you can ship them, you can't store them. So you have to have specific requirements, and it affects the design for those totes as well as the facility itself. The hazard classification also affects whether or not and when storage requirements, these are the flammable liquid storage cabinets, when they are required. It affects handling and transport of the materials through the facilities, whether or not you have to transfer it on approved carts, whether you can take that through exit corridors. Those are all based on the hazard classifications found in the fire code and NFPA. Likewise, as I mentioned previously, the mechanical code also has certain trigger levels based on the flammable or toxic characteristics of the materials. As far as the reporting requirements go, when you look at what are the reporting quantities, it really gets down to any amount for a lot of materials. If it's toxic, highly toxic, it's any amount. If it's detonatable, class 3 or 4 oxidizers, it's any amount. So you can get down to having to report almost any threshold quantity. I know one of the things, how that's broken out in the city of San Francisco, for instance, their local adoption says, well, what we're talking about is a laboratory, anything over 100 milliliters they want in your inventory. And to be inventoried down to that level, you're talking samples, aliquots, everything, is a very very laborious type of requirement for a laboratory. Okay? So you need the effective monitoring or some type of inventory tracking system so that you can adequately handle those materials. So on this, I want to maybe change it over to Brian in ChemSW and let you know how they handle some of these chemical inventory tracking systems and where the standard Excel spreadsheet that the laboratory tech may keep or the PI may keep may not be adequate to meet your reporting requirements. Brian?
All right, well thank you, Jeff. And starting off on that note, the many organizations that don't currently have an inventory system do use these spreadsheets, whether it's managed by the labs and the researchers within those labs, or possibly exports from an ordering or ERP system, or even worse, no tracking methods at all. And at some point, when it comes time to generate these types of reports that Jeff is referencing, you hit a point where it's just no longer efficient or effective to pull this information and be able to gather this for reporting form through these manual processes. And this is a lot of times based on these spreadsheets and manual processes being out of date, whether the researcher's not managing their spreadsheets in real time as new inventory arrives, or possibly handing in the same spreadsheet year after year with no actual changes. When it comes time to the collection aspect, you'll find that you'll have mismatched formats. So different labs may be tracking their information with totally different information, or even in a worst case scenario, not enough information to be actual generate the reporting that you need. For example, classifying materials, say your isopropyl alcohol, as a flammable liquid, and being able to report on that, which requires a lot of manual research and compilation of that data. There's other aspects as well. These reports and information needs to report not only on the quantity that you have, but also the status of those, whether it's the storage, the use open or use close that Jeff mentioned as well. And it's all very key as a part of that process. And when you reach this point, that's really where it's time to look to an inventory management software program like SysPro that can track materials on site in real time using inventory best practices. And the best practice of chemical inventory, it has to be extremely adaptive to everybody using the system. Not only the chemist ordering supplies and using the information to be able to locate the chemicals, but also to the gatekeepers managing the system as well. Inventory purchasing has to be streamlined. We need to be able to capture all items coming into the facility, including things like email triggers that notify gatekeepers when you reach a specified amount within certain areas, or certain chemicals have actually arrived on site. So keeping an eye on things like peroxide formers as an example. And finally, having a method to accurately remove information from the totals as well, so we can actually retire some of these bottles when they've actually become empty, which a lot of times when you get into these spreadsheets is just not maintained over time. So regardless of what chemicals, what supplies you have to keep on site, using a best practice system, all items are barcoded and categorized upon receipt. So that way they're all entered into inventory, they're all labeled, making sure that your inventory data is always accurate using these systems. Having an accurate system is actually what makes it easier to maintain your regulatory compliance through either ad hoc reporting or in February, March timeframe when a lot of these reports are actually due with different organizations. So there's several key factors involved with chemical inventory management, and you can see them listed here. First being, what actual materials are there at your facility, at your organization, and being able to classify what these types of materials are. Moving on from there, you have where these materials are located, knowing what control areas they're in, and making sure that you're in compliance with those different maximum allowable quantities. In terms of that, you have how these materials are being stored, whether being stored in the appropriate storage areas, whether it's a flammable cabinet or in a fume hood for open use systems, and being able to report on that and know without a doubt where those chemicals are. And having one of those best practices inventory systems is going to give you the answer to all three of these questions immediately. If an auditor ever walks into your facility, they can point to any item on a report that you can generate. You can take them to that specific area and actually prove to them right there that the item is actually in the same location that the report is showing. So again, you'll gain that visibility and very easy aspect of being able to pull information from your system. So getting into the management itself and the basis for having accurate chemical inventory, again, it's all based around a best practice system. It's absolutely critical to make sure that you actually have the chemical approval process for new chemicals coming in, so that way you have visibility on new items. One of the key things that we deal with a lot of customers is these free samples that a lot of manufacturers provide. They're often brought into the environment outside of an ordering system, so you have a possible failure point without having a gated approach to having new items arrive at your facility. So having these free samples come up or without any sort of a approval process or gated receiving process, these free samples are often very toxic. They tend to slip through the cracks, which causes a lot higher risk for not only your researchers, but also higher management and disposal costs, which really impact the organization overall. Now, what can you do to really bring these issues under control really ties into the inventory system itself. The first is the actual, beyond the best practices, is actually barcoding materials upon receipt. And what that means is before the item actually makes it to the laboratory itself and it becomes in the researcher's hand, it's already tracked and encoded. So that way the researcher doesn't have to worry and spend their time worrying about maintaining spreadsheets or updating the inventory system. It's already tracked and controlled before it gets to the point where it becomes in use. These expiration dates also need to be tracked in real time. Very critical for things like peroxide foamers of being able to store and report on when items actually need to be removed from the facility or possibly requalified for continued use. You want to isolate hazardous materials to make sure you're not accumulating more than's necessary. This is a direct impact to the safety of your environment for your researchers, and to make sure you're maintaining compliance with not only the building codes but also your fire codes as well. And one of the other most key aspects is, of course, is having the real-time capabilities. So as containers are moving throughout the facility, they're removed from actually being consumed, whether it's a lab pack or the actual simple disposal process and arrivals, that it all takes place in real time. And again, that's going to give you that visibility into the system and get away from the static spreadsheets that many organizations use without having the centralized system. And as Jeff has pointed out earlier, a lot of organizations just don't realize the range of regulations that govern a facility and that use chemicals. And the participants in this webinar actually are very familiar with that. The researchers are primarily concerned about their research. They tend not to worry as much about the regulatory aspect, just the simple SDS controls that they may need to follow to ensure safe handling. And that's where having this centralized system that benefits both parties. The researcher has the visibility into the current inventory, as well as for the industrial hygienist to be able to stay focused on the reporting aspect, compliance, and making sure that you can file accurate reports quickly and easily. We've actually had some customers report that going from a 2-month-long process of these clipboard calculations and manual collection and compiling of data for the reporting was dropped down to a process lasting about 2 hours long. So there's definitely some time benefits in the process of having the centralized and best practice inventory systems. So basically, in summary, the successful compliance is really knowing how the regulations affect your specific organization, being able to record that information on materials and reference that, as well as being able to streamline workflows both from the receiving, the management, and the disposal aspects to make sure that you have accurate reporting and safe environments for your researchers within their labs. So at this point, what I'd like to do is open up the floor to some general questions and answers. And we'll start talking to the participants here today. So Ed, do you have a question lined up for us from participants here?
Yes, I do. I have several questions. Let's see, the first question, this I believe is for Jeff. Do car doors serving control areas require separation as well?
No. Corridors are not required to be separated from the control areas they serve. And in fact, under the current code, the corridors aren't required to be fire rated at all in a sprinklered building. So you could have a multi-control area building that, say, has 4 control areas but has no rated fire or egress system.
Okay. Yeah, I think this is another one for you, Jeff. The L occupancy is only for California, but are the rest for U.S.?
Yes, the group BFS examples, as well as the H1 through H5 designations, are applicable to all jurisdictions in the U.S. that are based on the international code as their model code. The L occupancy can only be used outside of California if it's approved as an alternate means and method of construction by those local jurisdictions. It should also be noted that even within California, the L occupancy is not a mandatory construction standard for laboratories. It's just an optional design standard.
Okay, thanks. Next question. How do the reportable quantities compare to environmental reporting requirements?
The reportable quantities and environmental reporting requirements that are referenced under SARA I've used kind of interchangeably. They're totally independent from any reportable or permit quantities under the fire code, though. They go to different agencies and therefore have different thresholds and different classification definitions from SARA versus the fire code.
Okay, thanks. And this is a question for Brian. How can the ChemSW software be integrated with the California Environmental Reporting System?
The SERS reporting system, it's actually very easy. We've worked with several customers to develop turnkey reports where you can actually export your information directly to a spreadsheet format like Excel and either plug that information into the electronic systems of the form or submit the data directly to the local agencies. So that's one of the main aspects of having this information stored in a centralized inventory is it makes it very easy to extract it in different formats, whether that's a SERS, a Tier 2, a toxic release inventory, or even the fire reporting aspect. It all comes from the same centralized source of information.
Yeah, let me just add on that, the SERS system, if you export, it does put it into the Excel format that SERS allows as a automatic upgrade. So it has the same column headings and things like that that SERS uses in order to facilitate that transition, that upload.
Okay. Another question, how do you control secondary containers and mixtures, primarily in vats or cleaning tanks?
I guess I'd handle that from a design perspective. The fire code requires incompatible materials to be separated in separate secondary containment, and the primary containers also have to be separated by either a distance of 20 feet, a non-combustible fire partition, or some type of fire-rated cabinet. So you really got to think into how that complies, how the design complies with that. And it's difficult for vessels that are in process. You recognize that, so it has to be kind of handled on a case-by-case basis. I'm not sure there's something I can say other than making sure that the design meets that criteria is the only kind of guidance I can give on a general basis.
Okay. We've got several more questions here. I'll try to get to as many as we can in the time we have remaining. How are containers tracked that may move between labs or areas?
It's a good question, and a lot of that is keyed in on the inventory system itself. And our CISPR application uses barcoding technology to be able to very quickly and easily perform just a few barcode scans to move a container from one location to the other. That's a very key part of any inventory system, is being able to make sure you have very simple and effective management processes to maintain compliance and accuracy of your inventory system.
Okay. Another participant asks, how will EH&S impact these regulations?
The fire code really isn't taking the global harmonization system into account. They're going to stick with the way that they have always defined materials and will continue to require them to be reported according to their definitions, regardless of what the EH&S system gets adopted. Because again, it's not a code-mandated type of process, whereas the fire code actually has the equative, is equitable to law. It would use it as a standard, but it's not going to replace the fire code definitions.
Okay. Next question. What's the typical cost for a barcoding system?
And that can very much range by customer. So for the pricing type information, what we'd really want to do is actually have a conversation with the different organizations and find out what systems can actually best fit their needs, because we do have within ChemSW several different offerings. And our last slide here has an email address that you can contact to actually get more information on that, and we can delve in a little bit more about what your requirements are, get a needs assessment, and really make sure we get you even a tailored demonstration to show you a system that's going to work well, and pricing information along with that.
Okay. Participant asks, is this fire code applicable to India?
No, only if, some of the jurisdictions like India, we're dealing with projects in the Middle East as well, and in Philippines and Malaysia and stuff for that matter, where they require the design for the construction of a facility, say for an international company, to adhere to the standards of their home jurisdiction, in which case, yes, if your primary company basis is in the United States, most of those types of other jurisdictions that may not have their own model code would use this as their design standard as well. But it's not specifically adopted in India by reference.
Okay. When was the L occupancy for California effective?
When was it effective? It actually went into effect in with California, the 2003 code that went into effect. There was a gap there for a little while. Usually the codes are adopted on a 3-year cycle. In California, there's just a little bit of a hiccup in that. It actually at one point went through a 6-year cycle. So it right in the middle of it is where that transition was made.
Okay.
2003 International Code was adopted as the 2004 California Code, and that's when it really came into effect.
Okay, another participant has a question. What is the automatic sprinkler impact on secondary containment capacity?
It depends on the quantities of materials that are stored. If you exceed the requirements, there's a threshold that says, okay, the container size and overall quantity dictates whether or not you have to contain the fire sprinkler flow. For most materials, say for instance it's like 1,000 gallons aggregate quantity, until you exceed that threshold under the model code, you would not have to provide containment for the fire sprinkler system. If you exceed that requirement or the jurisdiction requires you to take the fire sprinkler flow into consideration, it's usually about 20 minutes of flow over the design area for the sprinkler system.
Okay. We're getting close to the end. I'll go on to the next question, and Rick, hop in when it's time. The next question is, do you also have a solution for chemical use approval evaluations?
We do. The CISPR application does feature capabilities of gating new materials entered into the system so that they can actually be received and barcoded, categorized, and dropped to the labs until an approval process is met. So that's one of the ways that we have of coming up with a solution for these free samples that come in outside of the ordering process, and they can be rejected at the point of receipt and returned to the manufacturer and actually kept out of the labs if necessary.
Okay. Next question, are there particular limitations on storage of flammable materials on the roof of a B occupancy?
The roof is really not, it depends what you call on a roof. If it's like an equipment enclosure, like a penthouse or doghouse for, say, your HVAC system or something, that would have an occupancy, and as such, it would be limited to the control area amounts. If it's truly open, and therefore doesn't really have an occupancy standard, there is no specific limit on what you can do and how much you can store up there. I mean, that was the idea. We went to a project in China one time, and we wanted to put an storage, flammable liquid storage room on the first floor, and the fire marshal in China said, no, you're going to put it up on the roof, all right, because if it blows up, I'm not going to lose the building. So you have to look at it of how it's built and how it's stored. Is it confined, or is it actually in a defined occupancy?
Okay. The next question, I currently use CIS Pro, but I know I am not using the full capability of the system. Is there a course or something that I could take to learn how to better utilize the system?
Yeah, absolutely. We do offer training sessions, both as an online web presentation, very similar to what we're doing here today, as well as on-site services with the possibility of doing some hands-on exercises for participants. And we have some sample training sessions that we use, and we can also tailor those to meet whatever needs that you have as far as learning the system.
Okay. And I think this might be our last question. Is Group L only, are Group L only laboratories in a multi-floor building? Can it be used for a lab that is standalone?
It can be used as a standalone occupancy. It is most advantageous because of the additional construction requirements required for a Group L. It's usually not advantageous to build an L on the lower floors. I mentioned the fact that fire-rated corridors were eliminated in sprinkler buildings. Well, guess what? If it's an L occupancy, California was so adamant that they wanted the rated corridors that they put them back in for an L occupancy. So providing that type of construction is kind of outweighs the costs or the advantages on the lower floors, but you could have one.
Rick, do we have time for any more questions?
If you want to take one more question, you could do that. There was one about Department of Homeland Security that Brian wanted to answer.
Oh, okay. I'm not sure the questions are lined up in the...
I can ask that one. It was, can this software also pull the information for Department of Homeland Security reporting requirements?
Yes, it can. We can actually pull information for the top screen report as well as give you insight into where the totals are. So if you have a particular material that has a higher quantity than you were expecting, we can of course drill down from there and let you know specifically what areas they're stored in and provide visibility. And again, one of the other key points behind having a centralized inventory system is not only for fire reporting, but also state and federal agencies that require this type of reporting information. It's again all keyed on the same inventory data, the same real-time systems, so that any time you can go in and run one of these turnkey reports and see the information you need, so that there's no surprises in February and March. You're well aware of what's going on and can maintain your inventory in advance of when the reports are actually due.
Okay, and that's all the time we have. If you wanted to have closing comments.
Sure. Thanks, Rick. I'd like to thank our sponsor, ChemSW, and our presenters, Jeff Tarter and Brian Billings, for sharing their insights. And finally, thanks to all of our attendees today. I hope you'll join us for our next Synergist webinar coming up in a few weeks on May 8th.
Yeah, and this is Brian, and I would like to thank the AIHA as well as all of our participants as well for spending your time here with us and the questions that we've been able to answer.
Yeah, this is Jeff. I'd also like to thank AHA and also the participants. I mean, it's from this side of the fence, a lot of times it's nice to be able to talk with authoritative and knowledgeable personnel on these issues, and it's I applaud you guys for wanting to learn more, and hopefully it helped expand your knowledge on some of these requirements.